My name is Ben Reed. I am Managing Director of HamiltonJet, and I am really pleased to be presenting you the story of how we have validated the HamiltonJet EHMX system, which is our own high-speed hybrid water jet propulsion system. We're a New Zealand-based firm since our foundation over 80 years ago, founded by industrialist Sir William Hamilton, and still family-owned and privately owned today. And what that's allowed us to do is maintain a singular focus on water jet propulsion systems and the related control systems and peripheral systems that support them. We think that's a really important part of our value proposition to the market. This is an industry that we really understand well, and we believe we're the clear market leader in terms of the output of water jets from our factory. We believe we're about twice the size of the next nearest competition. And this is a good example of an application that might use some of our larger water jets. This is an oil and gas crew supply vessel in Azerbaijan, a typical application where high speed and maneuverability are absolutely critical in approaching offshore oil and gas structures. To give you an idea of how water jets function, they're essentially a water pump that is not the engine. The engine would be separate and, of course, could be a diesel engine or an electric motor. It doesn't really matter what turns the shaft around. And you can see how water is drawn up from underneath the boat and accelerated out through the steerable nozzle. And also you can see the section of the reverse deflector, which allows the water jet to give 360 degrees of thrust vector. And when you have multiple jets on a vessel, that creates incredible maneuverability. And we also make the electronic control systems that control not just the water jet, but actually the whole propulsion line, engine, gearbox, and water jet. They're all consolidated into single control heads at the helm, and that's where we can do some particularly impressive things using those jets. The world of marine is seeing some significant movements, just like the world of industry is, in key areas of technology development. And this is something that we are both tracking and being very active in as a company, particularly in these three key areas. So why electrify the vessel at all? Well, firstly, there's the environmental benefits, fossil fuel burn reduction in particular, lower emissions, and legislative and contract requirements increasingly in the world. There's also a benefit in the quietness of operation, as we've seen in particular with our system. Lower speed transit and maneuvering on electric only really is a quiet and serene experience. And industries like tourism particularly appreciate that. Pleasure crafts particularly appreciate that. So there are a number of areas where the quietness of the vessel is a real advantage. And lastly, it's lower maintenance. We have been working with diesel engines in the marine industry for a very long time, and anyone who operates boats knows that they're one of the most important and most needy parts of the boat in order to maintain and keep working properly. And there's a genuine opportunity here to reduce the amount of hours on those engines and ultimately eliminate the diesel engines altogether in favor of electrical components that need far less maintenance. The biggest challenge, though, in electrifying, in particularly our industry, our business segments, is reducing carbon emissions while still going fast and far. It's quite straightforward to be able to go, say, all electric if you want to go fast and not very far, a short run across a bay in a harbour environment. Or if you want to go slow and far, which is what a lot of electric vessels are doing these days, 9, 10, 15 knots at the most, and covering reasonable distances. The real challenge is, as the vessel speed goes up, the hull resistance increases, and rapidly batteries become depleted, and energy storage becomes a real issue in terms of the weight and distance trade-off that you have to make. So we sort of define this really as almost the metaphor for what we are faced with as a water jet propulsion business, is how can we enable our customers to still go fast and still go far? A couple of examples of applications that would want to do that are ferries. Ferries are great for certain types of electrification because they do consistent routes and they do them at consistent timings. and they spend constant times on the dock. So regular and consistent routes are an advantage. That gives you onshore charging possibilities. And the key is to use electricity from renewables from the shore rather than using the diesel engines to generate electricity. And people don't want to get where they're going slower. These are often commuter ferries, and journey time is really important to people. But they also do a good deal of low-speed operation between 0 and 8 knots, maneuvering in and out of harbour, going through speed-controlled zones. So a boat like this lends itself to a solution that's going to be able to use electric only at lower speeds, but still be able to use the energy density advantages of diesel at the higher speeds. Wind farm support would be another really good example of an application that might need to go 50 miles offshore to drop technicians onto wind turbine pylons. But when it gets there, often they drop off groups of technicians on 4 or 5 pylons and spend the day loitering, waiting for them to finish their work. So this type of vessel is also really apt to being able to go fast on diesel and then to be able to loiter around on electric only. These are really good examples of applications where hybridization is a great stepping stone to maybe full electrification with something like hydrogen fuel cells in the medium-term future. Now, we as HamiltonJet have worked on many vessel projects that had hybrid or hybridization involved in them, electrification of the driveline and hybridization. We're into double digits now in terms of the number of boats that have been launched with HamiltonJets and those types of systems. And what we've noticed up until we launched our own system was that complete solutions were rare. And the trick about hybridization in particular is integrating the pieces together so that they function in a way that people would expect. We all drive around in cars and we see cars as clever as the Toyota Prius and other hybrid vehicles. They are seamless in the way they deliver power to the road, even though they're actually playing quite a complicated game between the electric and the petrol engine in that case. Integration, one size fits all, is not possible in this kind of context. Boats are different sizes. The systems are complex. The controls integration is complex. The mode changes from diesel to electric are complex. And cost and weight are always a challenge. So in facing those types of issues when we'd worked on vessel projects as just the propulsion system provider, it really brought us to the conclusion that there was an opportunity for us to take a leading role in integration of the driveline. And as I said, from a control system point of view, we've done that for a long time. We've controlled the engine and the gearbox and the water jet control surfaces into a single seamless set of controls at the helm. So last year we launched EHMX, which is our electro-hybrid drive system. This is a combination of our AVX control system, and it's working in concert with batteries, engines, gearbox, electric machines, and our water jets, in this case a small model, the HTX30. We saw the opportunity to do this integration, and one of the things that we did is realize that hybrid power take-in gearboxes are actually quite heavy, bulky, and cumbersome. And wherever possible in our system, we like to use a through-drive motor. It simplifies the mechanical installation and also minimizes weight and cost. So this would be a fairly typical example, maybe at the smaller end of what might make sense from a cost and weight point of view to hybridize. And this is actually the model for the boat that we ended up building. Our scope of supply in that system still isn't quite everything. We're now providing water jets, the integrated electronic controls, the electric machines and the inverters and the power electronics, the cabling, and the shore and hotel load inverters. We still leave engines and gearboxes to an owner-operator to select. We still recognize that many people have preferences based on local service and support. So we are agnostic to engines and gearboxes. And peripheral systems as they get more distant from our systems, such as cooling systems and air conditioning, we don't provide, or the onshore infrastructure. But we're becoming expert in these areas and are able to offer very good integration advice on them. And an optional supply from us is batteries. We sometimes do and we sometimes don't. And it is all integrated with our AVX control system. And this was core to the concept. We wanted to remain the propulsion system controller. We've seen installations with extra screens, extra levers, extra buttons to manage hybrid system power flows. We felt it was really important that we maintain the simplicity of a single control set at the helm with single information display. And to give you an idea what we mean by that is this graphic. So we've got our throttle levers down at the bottom. There's a power curve here, and to explain, the grey line is the available power for the engine, which peaks out about here, and this line is the power absorbed by the water jet. So there's a gap, and we can use that gap for charging the batteries. So in our case, in this example, we're in automatic mode. So this is going to drive a bit like a Toyota Prius. The point here is that in the front half of the lever operation, when we're at low speeds, the vessel is in electric-only mode, assuming the batteries have a sufficient state of charge. And you can see here in this example, we're at 92%. So the vessel would start off at electric-only mode. It's an operational decision whether the operator has warmed the engines up by then or not. But for the first part, the engines would be off, and as the levers move up, you stay on electric-only mode up to the point where there's a detent in the lever, indicating that's the end of your electric-only operation. The moment the lever is moved past that detent, in automatic mode, it will start the diesel engines and also start recharging the batteries at that moment. So you can see the engines start, it moves from electric only to generating and starts to put some electricity back into the batteries as well. Continuing in that automatic mode, the levers can continue to be moved, increasing power, and that is increasing the power of the diesel engine, and if necessary, it is charging the batteries to the point where they're full. And then we reach the point where all of the available engine power is going into the impeller of the jet. And if the boat is configured to have a boost mode, that's where we can add the electric motor to the diesel engine, we can then go into a final mode where we start using the power again and boosting the speed up to even higher levels. The system also has a manual control mode. We've absolutely recognized that some operators will want to be in full control of what is happening on their vessel in terms of where the power is coming from. So if the vessel is in automatic mode, it simply takes a touch of a button and we can put that into diesel-only mode, and the system under the hood is making all of the necessary changes to the configuration of the driveline to deliver that. So fully flexible was a mantra that we had during the development of this product. The electro-hybrid drive system advantages for us, we believe integrating the controls is a really important thing on the already cluttered console space in modern vessels, automatic and manual modes, through-drive motors where they're practical. We are also then very much in charge of minimizing weight and working with the boat builder and the architect to do that. And the whole thing comes with a consolidated warranty with our name behind it. And we also offer the design optimization service. We don't charge for that in the early stages of development if you're in exploration mode. Proven hardware and HamiltonJet's commissioning behind the whole system. I guess the purpose of this presentation is to talk about how could we really be sure we, as a previously water jet only manufacturer, were going to be confident in delivering a complex system like that. Well, our confidence in our systems integration expertise was already high, but we definitely felt there were some areas we needed to learn more on. So we took the bold decision of spending around about $3 million New Zealand dollars on a test vessel for ourselves that could validate that drivetrain and the system components within it. So we built Aria, that's the vessel name, and that is our technology demonstrator. Aria is a 15-meter foil-assisted catamaran, 5.4 meters beam. It's about 20 tons, just under 20 tons in displacement. Surveyed under Maritime New Zealand rules and able to take 20 passengers. The performance of the boat, this is one of the key things we wanted to validate. So working with the naval architect and the electrical machinery and diesel engine suppliers, we predicted 37 knots on diesel. We achieved 37. That was faster than the previous boat had gone before we put those HTX 30 jets in, which increased its top speed. Electrical top speed, we thought we might get 10 knots, we've got 9. And boosted, we thought we might get 43 knots. We're getting 41 knots at the moment, but there's still some optimization to be done. And the vessel does have quite a windage area up there that we hadn't accounted for. Extra weight, 1.3 tons was the prediction. We actually came in at 1.1, which we were very pleased with. So the vessel was launched around about the beginning of this year from the boat builder as a finished vessel, went through commissioning, went through survey, and immediately went up to Auckland to act as a demonstration platform and using the event of the America's Cup as an opportunity to bring together guests, sadly in New Zealand only, but hopefully soon we can bring from overseas. We had 9 days on the water, and we were bringing operators and boat builders and naval architects, the core people that we work with around the world. We had no technical issues in that period. We're really pleased with the fact that the systems performed reliably and demonstrated the technology in the way they should. And the kind of feedback that we had from people was, well, firstly, they're impressed often by the maneuverability and capability of water jets, particularly using advanced controls features like station keeping and precision maneuvering using GPS feedback. But in particular, people loved that silent operation leaving harbour. There is something quite special about being on a boat that normally would sit there vibrating like crazy with 2 diesel engines under the hood vibrating and creating noise, leaving silently and serenely, and then later loitering in that way as well. And the vessel, having finished that duty and done a great job for us in promoting what we could achieve, is now back in Lyttelton here in South Island, New Zealand, and you can see it there parked up next to our other technology demonstration boat. You can see she's a good deal bigger. And the reason we chose a vessel like this is because we wanted a platform that was much more representative of the type of commercial and industrial and even military operators that we tend to sell our water jets into. It's much more equivalent to size, and many of those operators use catamarans. The key learnings from this exercise for us, it's been really interesting to be our own customer for the very first outing of EHX. And the first thing that we have validated is that hybrids are a very effective way of getting those carbon emission reductions whilst still preserving the ability to go fast and far. Now, a question we're always asked is how much carbon do you save? And of course, you just can't give a single answer to that. It's to do with how much shore power you can bring on board the vessel, what you've sized the battery capability as, and what your duty cycle is. But in some of our vessel studies that we've done, we are seeing significant savings in things like ferry operators who can run almost all of their routes on electric only and only use the diesel for those short sprints. We've certainly proved that good integration is the key to a successful vessel. I think this is the best hybrid vessel that we've experienced as a company in terms of the way it performs and the way that integration has paid dividends in the simplicity of operation at the helm. Our predictions can be trusted. We're very confident that our predictions of how these systems will perform and the durations that you might get out of the batteries on different modes of operation, respecting the limits that you need to ensure battery life, we're confident now in our predictions and that they can be trusted. We've also seen that advice from us to the boat builder on how to integrate the peripheral systems, in particular the cooling systems necessary for this operation and the fire suppression systems for battery spaces, etc. That is essential information for us to be able to share, and having had a direct experience of that ourselves, we know what is required. We also now know that people believe what they can see. Fascinating sales conversations with some of the ferry operators in New Zealand, where genuinely moving forwards with environmentally responsible purchasing decisions became so much more tangible to them once they were able to ride on something that showed them the technology working, and they could see how it fit in their operations. And as the world opens up, we will be welcoming people to New Zealand to experience it for themselves. And lastly, we believe that experience is worth paying for. It is something that there's no doubt hybrid systems are more expensive and more complex than conventional drivetrain systems, but we believe that we are an excellent partner in terms of being able to deliver a functioning vessel that meets the customer's expectations. Thank you.